This is a demo for Practice 8B, Degrees of Freedom. How we find degrees of freedom. In the independent samples t-test, two separate groups of individuals produce scores, the individuals in condition 1 and the individuals in condition 2. So for example, condition 1, Zoom class attendees, and we have 25 individuals. Condition 2, in-person class attendees, and we have 17 individuals. Because we have two means, one for condition 1 and one for condition 2, we have to use degrees of freedom for both groups to figure out degrees of freedom total. So, degrees of freedom total equals degrees of freedom for 1 plus degrees of freedom for 2, which is the same as the n for group 1 minus 1 plus the n for group 2 minus 1, which is 25 minus 1 plus 17 minus 1, which is 24 plus 16, which is 40. So here are some examples using the formula df total equals df1 plus df2. A researcher assigned 10 individuals to have a bird feeder outside their window and 12 individuals to have no bird feeder. What is df total? Well, the answer, we just know that df total equals df1 plus df2 equals 10 minus 1 plus 12 minus 1 equals 9 plus 11 equals 20. Concentration scores for 32 people attending on Zoom and 18 people attending in person were compared using an independent samples t-test. What is df total? So once again, we have to take each n, subtract 1, and then add those two together. So answer df total equals df1 plus ds2 equals 32 minus 1 plus 18 minus 1 equals 31 plus 17 equals 48. Another type of question that you'll see on the practice quiz involves something like this. An independent t-test will be used to test a hypothesis, and df total equals 75. Which of the following describes possible sample sizes for this test? So we're going to use the very same formula for solving this problem. We're going to use df total equals df1 plus df2. Substituting in, df total we know is 75 equals n1 minus 1 plus n2 minus 1. We know that we can use simple algebra to get rid of these minus 1s. We can add them to the 75. 75 plus 2 equals n1 plus n2. And so then we have 77 equals n1 plus n2. So now, any numbers that can satisfy this will be adequate. For example, we could have n1 equals 30, n2 equals 47. I know that this is a possible answer because 30 plus 47 equals 77. Another example. An independent t-test will be used to test a hypothesis and df total equals 24. Which of the following best describes sample sizes for this test? Same formula. df total equals df1 plus df2. 24 equals n1 minus 1 plus n2 minus 1. We'll get rid of the 1s by adding them to the other side. 24 plus 2 equals n1 plus n2. 26 equals n1 plus n2. And so anything that satisfies these conditions will be adequate. For example, e.g., n1 could be equal to, let's say, 13, and n2 could be equal to 13. We know this is adequate because 13 plus 13 equals 26. Another example, N1 equals, let's say, 16. N2 could equal, it would have to equal then 10, and we know that because 16 plus 10 equals 26. I hope this was helpful to you. That's all.